what should be an exceptionally quick video here, because this is just a continuation of your previous lesson on projectile motion, which is in itself the only prerequisite piece that you need for this lesson. Now, what we covered in the last lesson was standard form, was that our acceleration is always -5, which we will also see whenever we're working in vertex form. The initial speed was always the b value here, and that is the coefficient on your t term. And the initial height was always the constant added, usually listed right at the end, but it's the piece that's being added that has no t attached to it. Now, vertex form. You folks have worked with vertex form before. In fact, in the previous projectile motion lesson, you worked with vertex form a little bit. Now, vertex form gives us two different pieces. It gives us the maximum height, and it gives us the time at which that maximum height occurs. And the only new skill here that we're going to practice is being able to build these equations based off of some hints. Last time they gave us the equations, this time we're building them. That's it. That is the only new piece. So, Jackie throws a baseball up in the air at a speed of 23 meters per second at a speed, okay. So it's a speed and 23 meters per second. When is it 23 meters per second? When Jackie throws the baseball. And releases it at a height of 3 meters. Okay, now you can also notice not just that these are both initial settings, but you can notice the units, right? Meters, that's a height. Meters per second, that's a speed. So there are our initial speeds and heights. Determine the quadratic equation in standard form. So we're working in standard form right here. That calculates the height of the ball. Which one's standard form? It's right up here. All we need are B and C, the initial speed, the initial height. Lucky us, we have them right here. So we're working with h equals -5 t squared. Why? Because that's always the case when things fall on this planet. Plus 23t. How did I know it's 23? Because that is a speed, right? That's 23 meters per second plus 3. How do I know it's 3? That's the initial height. It's that easy. All right. What's the height of the ball after 4 seconds? You folks know how to do that based off your previous lesson here. I want you to pause the video, try it out, unpause, and see how you did. Fantastic. So we should be able to see that the height after 4 seconds, the height of the baseball is 15. 15 what? 15 meters. Right? The height is measured in meters. Okay, let's keep right on going. Now you folks should be ready for question 2. Okay, this time we're working in vertex form. I want you to try out the same thing. Frankly, not much should be new here. Even though the form itself is different, well, you folks have seen this before. You should be able to plot it in. I want you to try it out. Pause the video for question 2A. See how you did. All right, common mistakes. Don't forget this 2 here. Your t is your variable time. That needs to stay as your variable time as you're working through. H is your variable height. That stays as your variable. And 23 is the maximum height right here. Now, don't forget, in between the t and the 2 is a subtraction sign. It must be subtracted if our maximum height occurs at a time that makes sense. All right, now, what's the height of the football after 3 seconds? Again, nothing new here. Pause the video, try it out, see how you did. Good, so we're working here with 18 meters. That's the height after 3 seconds. How do we know that? We substitute in the value, t equals 3. We put that in where t was. We performed our bed mass and followed our way through. Nice work. And you know what, folks? It looks like there's not a whole lot of space right here, but there is one more question. What was the initial height of the football when it was released? Oh, hang on. They don't give us a t value here, do they? When it was released. That's the key. When it was released, t was equal to 0. All right, if t was equal to 0, and I wish there was space here, but there's not. If t is equal to 0, what I want you to do, I want you to substitute this into your equation, and I want you to see what happens. Fantastic, and following our bed mass, it looks like that occurs at a height of 3 meters. If you found a different answer, pause the video, double check where you are making your mistake. All right. Example 3, frankly, you should be able to handle this all by yourself at this point. I am just going to leave example 3 alone. You can handle it. I'm hoping at this point you feel a little bit more comfortable building your equations, your quadratic equations of projectiles, of objects that are in motion. You should be able to handle at this point the practice problems. Nice work.